Hello KCET warriors, welcome to Deeksha Karnataka YouTube channel. The wait for you is over. So today I am going to bring a very important tool for your success in KCET exam, that is formula sheet for your entire syllabus. So this formula sheet that I am going to show here today, you can download it, but the download link will be shared in our WhatsApp channel. There will be two PDFs, one for PU1 and one for PU2. Download them, keep it and use it for your reference, right? So the formula sheet is very important to revise quickly the day before exam. That's why we are sharing it now. So I hope that you all have the formula sheet with you. If you not, definitely you should go through it. This is a very good tool for you to revise the day before exam. Okay, so you can revise entire chapter like that. Okay, so what all we are going to give? We are going to give you chapter wise formula sheet, and each chapter have their own formulas listed over here. Okay, so you can see Coulomb's law, the basics of the Coulomb's law, the constants, and also if you put a dielectric medium between the charges, then how this value of R changes, that is also mentioned here. Electric field, obviously we all know everything, but still sometimes before exam you have to revise the concepts. That's why we are going to give you absolutely free of cost, but you have to join our WhatsApp channel if you have not yet joined, and you can download it. Okay, I will share one or two chapters with you without wasting too much of your time, because obviously you will get this as a download and you will have to check it yourself. There are obviously 14 chapters. I cannot show 14 chapters over here. So dipole moment, you can see the formula for dipole moment, the direction of dipole moment. Now electric field on the axis, on the equatorial plane, both cases it is given here. So you don't need to remember anything, just need to go through it and it will automatically be, you can revise. Torque acting on a dipole is given by P cross E. Potential energy of a dipole, sometimes students confuse. Potential energy of a dipole is minus P cos theta, and potential due to a dipole is V is equal to 1 by 4 pi epsilon naught P cos theta by R square. So as you can see, electric field varies with 1 by R cube and electric potential varies with 1 by R square. So sometimes this question comes in KCET, so you have to you don't need to worry. If you have gone through this sheet, it will automatically you can recall and answer. Now next is Gauss's law and application. So as you can see, infinitely straight wire, field due to uniformly charged infinite plane, heat, field due to a uniformly charged thin spherical shell. So all the formulas that is there in your syllabus are here. So inside the shell, outside the shell, electric field is given by this. Inside the shell, electric field is 0, potential is constant. Okay, now if you plot the graph of electric field due to a shell, the graph looks like this. Up to this point everything is 0, suddenly it drops as proportional to 1 upon R square. Okay, so this is a very important graph for your exam as well. Okay, now Gauss's theorem is given by phi is equal to q by epsilon naught and E dot ds equal to q by epsilon naught as well. You should also mention one important thing over here is that in Gauss's law, the flux is given by E dot A, okay, or sometimes EA cos theta. Okay, so this is something that you also have to remember. Now next, move on to the next chapter, electrostatic potential and capacitance. So here we have electric potential due to work done. What is electric potential? How can you calculate electric potential? If you know the potential energy, the U reference refer to potential energy, V refer to potential. Okay, potential energy and potential are different. Okay, potential is basically potential energy divided by charge. Okay, so and difference in potential between 2 points is basically given by VV minus VA. Okay, also for a potential at a point, if you start at infinity, Then when you reach the point, that gives you the potential of that point. And if you plot the graph of electric field and potential, electric field is steeper compared to electric potential. Electric field starts at high value and it goes to zero very quickly, whereas potential starts slightly lower value and it goes to zero slightly less slowly. So this is a comparison of electric field and electric potential. Just remember, electric field is steeper. E is steeper. That means the graph is start with a high value but goes to zero quickly as well. Now potential energy of 2 charges is given by this, 3 charges is given by this formula. Okay, all I hope you have remembered. And electric field, relationship between electric field and electric potential, Ex, x component of electric field is given by dV by dx, where y and z components are constant. Okay, similarly you can calculate y component and z component as well. Now parallel plate capacitor, capacitance of a parallel plate capacitor, C equals to Ka epsilon naught upon D, Q is equal to Cv. Series combination is given by this. For 2 capacitors in series, the shortcut formula is C1 C2 by C1 plus C2, and parallel combination is C1 plus C2 plus ... Okay, now if n number of capacitors each having same capacitance, you don't need to use these formulas. There is a very much more shortcut way available, which is equivalent capacitance is C divided by N, and in parallel combination it is N times C. Okay, so remember, if 2 capacitors, say both are 12 microfarad, they are connected in parallel, then you just need to multiply 2 with 12, you get the 24 microfarad as the equivalent capacitance. Similarly, if they are connected in series, 12 divided by 2, which is 6 microfarad for capacitors connected in series. You can use the similar principle for resistances as well, but in case of resistance, just remember series and parallel are actually, the formulas are opposite that of capacitors. Okay, in case of series combination of resistances, resistances gets added, parallel combination they gets added reciprocally. Okay, so the formula is opposite of the whatever formula you learn for capacitance. So one formula you learn, that formula will be helpful for resistance as well. Okay, now energy stored in a capacitor is given by half Cv square, and energy density, that is energy stored per unit volume, is given by half epsilon naught E square. So these are the all important formulas for your KCET exam. Now current electricity is, as I mentioned, in current electricity, current is given like this, Ohm's law is given by this, and the alternate form of Ohm's law, sometimes students get confused. What is the alternate form of Ohm's law or vector form of Ohm's law? J is equal to sigma E. Based on this, a lot of different questions came. So for example, electric field is equal to resistivity into J. So this question based on this formula is more common in KCET and in your board exam as well, but we are currently preparing for KCET exam, so this is a very important formula. Okay, next is current, drift velocity, current, current density, all the important formulas, mobility, everything is given here in one under one page, so you don't need to find everything and write it down. So here everything is mentioned one by one, so you can basically go through this and you can remember it. Okay, resistance and resistivity. Resistance is proportional to length, it is inversely proportional to area, so resistance is rho L by A. Now remember, area is pi r square for a circular cross section. That thing you have to remember, because based on the question it can be a circular cross section or it can be a square cross section as well. So area you have to calculate based on the question. Okay, resistance, dependence of resistance with temperature, which is given by rho T equals to rho 0. Basically remember that resistivity depends on temperature, not resistance singly. Okay, even though resistance is proportional to resistivity, that's why we can convert this formula for resistance as well, but the fundamentally resistivity depends on temperature. So if you want to calculate resistance or resistivity, anything is given, you just need to replace rho by r, you will get the same value, same answer. Okay, it does not matter whether you are writing in terms of resistivity or resistance, the formula remains same. Okay, now in some cases when the temperature are not 0, one temperature is not 0, then you have to write it like this. Okay, so so you have to write RT2 RT1, that is the resistances as at these temperatures, okay, and RT1 into T2 minus RT2 into T1, okay. So I know this might be a little tricky if you have not studied it, but anyway, just go through it, try to remember it. This will be very, very helpful in the KCET exam as well. Now resistances I already explained in the capacitor part. Everything is same as capacitor. Only thing that changes is the series and parallel is actually inverted for two resistances, R1 R2 by R1 plus R2. Now resistance you are using, obviously you are using since your class 10th, so I think you are more familiar with the resistance than capacitance, so you can remember the resistance formulas and apply the same thing for capacitance but in opposite way. Okay, now energy dissipated in a circuit is given by H is equal to VIT. Power is V into I or I square R or V square by R. Now this application depends on what values are given to you based on question to question. Okay, so this is the basic combination. Cells in series I will not explain any further. This is the last chapter I am explaining because this is the most important chapter. Cells in series, and cells in parallel are important. Now this formula, if you remember it like this way, this will be very, very helpful because you don't need to understand epsilon 1 into R1 or epsilon 1 into R2 or what is in the division. You don't need to do that. Okay, you simply remember EMF divided by corresponding resistance, and if you add them, okay, and in the division if you add reciprocals of the resistance, you will get the equivalent EMF when cells are connected in parallel. Okay, very important formula. Similarly, for parallel combination, equivalent resistance is same, 1 by Req. Now sometimes student confused, they calculate everything right, they forget that it is actually 1 by Req. Okay, it is 1 by Req, it is not it is not Req itself. You have to take the reciprocal of the value that you have calculated, so don't make a mistake in there as well. Okay, now current is given by, you can calculate current in 2-3 different ways. One of the easiest way is epsilon equivalent divided by external resistance plus R equivalent. Okay, so this is the like that all the chapters are listed over here, Lorentz force, okay, and so far and so on. You can check all the chapters as much as possible. I have tried to give some diagrams as well. The value of mu naught by 4 pi is also mentioned. Sometimes that can be confusing. Force acting on a parallel wire is also there. All the chapters, chapter wise, all the important formulas are listed in this sheet, so don't forget to download it, and download is available in our WhatsApp channel. Link of the WhatsApp channel given in the description section of this video. So go there, download the sheet, have it with you, check both PDFs, PU1 as well as PU2. I hope that this will be very, very helpful for all of you. All the best for your preparation. I will be back with more lectures very soon. Till then, bye.